Hello everyone, welcome back to the next session of multimedia system. Let us continue our discussion with the topic the data compression. In the previous session we had discussed about the various compression methods and the generalized compression method with respect to the MPEG format, that is the MPEG 1. It is also referred to as the general MPEG format or MPEG conversion or MPEG 1 conversion. Let us extend our discussion with respect to the next format, that is MPEG 2 format. As we know that it is an extended version that has been generated or derived the features of H.261 and 263 formats. So as MPEG 2 is also known as H.222, that is H.222 or H.262 format. It is also referred as the same, that is H.222 or H.262, which has been defined by ITU as a standard as a generic coding of moving pictures and associated audio information. The MPEG 2 is widely used as a format of the digital television. This is very important. Why did this format come into picture? This format mainly came into picture in accordance with the digital television signal that are broadcasted by the terrestrial, means over the air. For broadcasting, this signal is very much supportive, or it might be through a terrestrial, that is air, or it might be a cable, or direct broadcasting through satellite. So this is very much helpful for broadcasting. So this is about the MPEG 2. Then what exactly do you mean by MPEG 2? What exactly do you mean? MPEG 2 is also referred as MPEG 2 as an audio and video codec standard. This is very important. I underline this word. Audio and video codec standards published by the Moving Pictures Expert Group. Now you know that MPEG stands for Moving Picture Expert Group, whereas JPEG stands for Joint Photographers Expert Group. Now it has been standard that has been defined for a audio and a video codec standard. One more thing you need to know is, what do you mean by codec? That is very important. Now what is codec then? Because the MPEG is defined as an audio video codec, many times you might have seen the audio codec, video codec you've been encountered in these kind of standard words. But MPEG 2 is a combination of both audio as well as a video codec. So it is very important to understand the codec. What do you mean by that? It is used, when you talk about codec, codec is a technology used to compress the digital broadcasting of video over a media. Means it's a technology which is used to compress both the audio and the video. When sometimes you might have encountered audio codec, means it's a compression media that is being used for compressing the audio signals for the broadcasting purpose. When I talk about video, it is compression of video signals for broadcasting, whereas here it's a combination of both, as MPEG constitutes of two elements, that is audio and a video. Here we are talking about the compression of both audio along with the video for broadcasting. So here you see that. Why is MPEG used? For broadcasting MPEG 2 mainly. So this kind of technology is called codec, that helps to compress. Now what exactly you mean by codec? Is it something new? Is it a device or anything? It can be considered as a software that compresses your video so that it can be stored and played back. So this codec can be generally referred as a software. It is very much useful for both the purpose. One, the compression of audio and video, and also the playing of those compressed audio and video. So when you talk about the codec, you can generally refer it as a software that compresses your video so that it can be stored and played back whenever you want. The common codec includes H.264. See, MPEG 2 is referred as H.266, 222 and 262, and the improved version which is commonly used codec is the H.264. That is the improved version which is often used with high definition digital videos and distributed video content. This is the very key concept of the codec. Then when we talk about the MPEG, you know what is the MPEG 2 and what do you mean by that and what do you mean by codec. Then what is MPEG compression? You know that the general compression of MPEG we have already discussed along with the JPEG and MPEG. The same procedure is involved, but there is a slight differences between one another. Let us look into the MPEG 2 compression. So when we talk about MPEG compression, it is an algorithm. There is no much difference between the regular MPEG or MPEG 1 compression technique. It also comprises the same technique, but the slight improvements is being done. So it is an algorithm of data that compresses the data to a small bits that can easily be transmitted then decompressed. The main intention is to compress the data into small bits so that becomes easy to transmit over the medium, and but the receiving end become easy to decompress. That is MPEG compression. And MPEG archives is high compression. Means here high rate of compression is achieved with respect to MPEG, and the rate of compression is very improved version. Means we can compress it with a high data rate and the high quality of compression is achieved. MPEG uses the lossy compression. This is common thing that needs to be remembered. It is of lossy technique. So MPEG, there is always a bit of loss or some of the data might be removed in order to reduce the size of the signal without the cost or without the huge loss of information. A bit of information which is negligible. Then how does MPEG compression work? Now how does it work? When we talk about the MPEG 2, we know that it's a lossy video compression method based on motion vector estimation. This is very important, okay, where discrete cosine transformation, quantization and Huffman encoding is deployed. So these methods we have already discussed with help of a diagram and various stages of MPEG compression. This same procedure holds good here also. And the lossy means the data is lost or thrown away. When you talk about thrown away, not everything, a bit of portion during the compression method. So quality after decoding is always less when compared to the original. Means when you do up a compression, a bit of information is always lost. So the quality is slightly needs to be negotiated here because we are losing some of the information in order to decompress the process of compressed data. This is the importance of the MPEG. This is how it works. Then what is the difference between the MPEG 2 and the MPEG 4? Because we always discuss the differences. The MPEG 2 and G4. We know that there is one more standard along with the MPEG 2, it's MPEG 4. Then what is the difference? See, when we talk about the MPEG, different versions are the bit level of improvements. There is slight improvements between one level of MPEG to one more level, but the working principle or the compression or decompression procedure holds good for everyone. Let us come back to this. Ultimately, both MPEG 2 and MPEG 4 are capable of maintaining high definition video quality. This is important. Means both are very clear. They can handle very high definitions of HD quality of videos. The difference, however, lies within the application. This is major important, means the where the application or which kind of applications uses these technique is the major difference. Some of the applications are very much compatible with the MPEG 2 and some of the applications uses the MPEG 4. Why is that? What makes it the difference is the MPEG 2 is always a commercial standards, means when we look about a very high quality of data, we go for MPEG 2. When we are not much bothered about the quality of data, when we are bothered mainly about the transmission of data, we go for MPEG 4. That's it. So this is the major difference. And one more thing, when we talk about MPEG 4, on the other hand, utilizes the high data rate of compression and smaller files such as the audio and the data to provide high quality video, and audio across the mobile networks uses the MPEG 4 format. This means here the MPEG 2 it yields very high quality data when compared to the MPEG 4. So here the compression rate is bit less, because since it is a lossy thing, if everything is lost, obviously the quality of information gets degraded level to level. But as here the quality of information is lost to a greater extent. When we talk about the quality of information is lost to greater extent, it is inversely proportional to achievement of more amount of compression, whereas here the loss of information is very less. So the compression rate is very less, but the quality is very good. So these are the major differences when we talk about the MPEG 2 and MPEG 3. Then which is better? This question arises. Which technique to adopt? Whether to go with the MPEG 2 or whether to go with the MPEG 4. See, unlike other MPEG formats, MPEG 4 can store still images, subtitles, video, audio and other essential data. So this is common thing. Today, MPEG 4 is the most popular video format that can open any that can be opened on any kind of media players. This is the thing. Why? It achieves high rate of data compression, one, and also it is not mainly looking for the commercial or industrial standard. When we talk about the commercial things, so where do we use this video and other things in a commercial way? The cinema industries, where they expect high resolution, high quality images. So they are least bothered with the storage property. Even the storage extends beyond the things like GBs or TBs, they are least bothered. They are mainly concentrating of the very high quality of images. There, in that cases, MPEG 2 is very much appreciable because it compresses very less. So rate of data compression is also slow and the quality is very high. Whereas in the case of MPEG 4, the compression rate is very high, means the loss of data is a bit more when compared to MPEG 4. So here MPEG 4, since it is more compression is achieved, it is very easy to broadcast the videos or the audio signals over the terrestrial, over the cables or through other media. So you can enjoy MPEG 4 files in most of the players like the VLC players, QuickTime, Windows players, Windows media players and many more. So that's why it is not that which to use or whichever is better, it is the application orientation. Which is suited for which MPEG format is suitable for particular application, we make use of it. Based on the transmission of broadcasting of information of media file, MPEG 4 is obviously much more better thing. That's why in every place MPEG 4 is very much useful. Then there is one more question that's been asked by students. So AVI, audio video interface. So which is better, whether to go with the AVI, which is a default one, or with the MPEG 2? Let us discuss with that. AVI or MPEG, whether it's MPEG 2 or MPEG 4, let us discuss in general AVI with respect to MPEG. So when we talk about the AVI format, it is totally uncompressed. This is the important thing that you need to concentrate. Whereas MPEG is compressed. One of the students asked me, sir, when we look into the AVI format, the movies in this format are very clear and very good, but you say the MPEG is the latest one, but there we don't find the quality as compared to the AVI. So answer for your question is here. See, look here, AVI is uncompressed. When you have no compression technique involved, there is obviously no loss of data. When there is no loss of data, you get very good quality of image, quality of data, which has been as and when it's been captured, as and then. So in what clarity of picture capturization has been done? The same quality has been done. Is been able to retrieve here. Whereas here, it is not so. Here compression technique is applied. When you have the compression, when we talk about the MPEG, it is obviously a lossy. Means some of the information is lost. So you cannot expect the original quality of image. That's why it is very difficult to compare AVI with respect to the MPEG. So here the quality is comparatively much more better than MPEG 2. Second one, the similar 1 hour video content is in 352 into 228 resolution. Let us consider. Consider a video, 1 hour video that can be used with a resolution of 350 into 288 resolution will take an almost 650 MB space when coded in the MPEG. Here. Why? It's a 1 hour video. Consider a 1 hour video of this resolution. When we try to store this in a MPEG format, it almost occupies 650 MB. So when we talk about here, that is the AVI, it is in GBs. See, just at 650 MB, we are able to store the 1 hour video. Whereas here, since we do not adopt any kind of compression, it goes in GBs together. Now you look the difference. If the storage is the main criteria, go with MPEG. If you want a clarity, the storage is not at all a problem, go with AVI. If you want to broadcast the video, you need to have lesser data, small data, go with MPEG. So broadcasting is not a problem. If you are using a DVD where the stored image or a stored video is played, go for AVI. So this is the difference. We cannot say that or bifurcate and say AVI is better over MPEG or MPEG is better than AVI. It is the method of adoption to that circumstances. based on the criteria, we can say that which is the best suited at that instance of time. So we don't compare any of the video format to be saying that which is better than that or that is better than this. So this is what with respect to AVI. Now let us look into the concept of MPEG-4. See, MPEG-4 is just an improved version of MPEG-1 or a MPEG-2. So it is an advancement version. We can refer it as advancement version of MPEG-2. So MPEG-4 is totally based on object-based compression. This is very important here. This is the highlight when we talk about the MPEG-4. So individual objects within the scene are tracked separately and compressed together to create an MPEG file. So I repeat this statement, the whole concept of MPEG lies in this definition. The individual objects within the scene are tracked. So each objects within the scene are tracked separately. If there are different objects, they are tracked separately and compressed together to create an MPEG-4 file. That's it. The compression technique for whole MPEG-1, MPEG-2 and MPEG-4 remains the same. But what is that technique or improved version that MPEG-4 is being known for it is the object-based compression. Each and every individual objects within the scene are tracked separately and compressed. See, tracking is done separately, but when they talk about compression, all are compressed together, so that if you compress it individually, there would be mismatch of the motion pictures. So they are compressed together to create an MPEG-4 file. The result is very efficient compression that is very scalable from low bit rates to a very high rate. This is about the MPEG-4. Then what does MPEG-4 exactly mean then? So when you talk about MPEG-4, it's a method of defining the compression of audio and video digital data. So when we talk nowadays MPEG, it has become a definition like that. So which kind of compression? MPEG-4. So why? Audio and video supports good. Yes. What kind of compression technique is used in that kind of technology? MPEG-4. This kind of device supports MPEG-4. That kind of player supports MPEG-4. So it has become a defining compression standard. So using of MPEG-4 includes the compression of AV data for web also. This is very important. See, when we talk about the MPEG-2 and all, we had not discussed about the web concepts. There we had discussed only till the broadcasting and storing. When we talk about MPEG, we mainly concentrated on storing of information, that audio and video. So on DVDs. And when we talk about MPEG-2, we extended our discussion or thought even for the broadcasting over the net. But now we are talking about the web concepts here. This is what that gave rise to MPEG-4. Here we are talking about the web. So what is that? When we talk about web, it is the streaming media when we talk about web. We might have seen, so with webinars and all the events in the day-to-day real activities, they go for live streaming, YouTube live streaming, Facebook live streaming, and lot of other data streaming, and also many of video streaming technologies have come up so that they support the real-time activities of streaming. So for that kind of technology, for having high data compression with less data transferable and very less amount of storage is been very much supported by the MPEG-4 technique. or web applications also. And also the same technology can be used for CD distribution, means you can record those things in a MPEG-4 format on this CD also. Voice, nowadays in a voice, that is telephone and video phone, both are using the MPEG-4 format, and broadcasting with the television applications are now becoming very easy with MPEG-4 when compared to the MPEG-2 standards. So that's the importance of MPEG-4. Now the main thing is we need to concentrate on the difference between the MPEG-2 and the MPEG-4, because this is one of the important questions that you can expect in the examination. They will usually ask, explain the MPEG compression technique in detail, or the procedure of MPEG compression. Also mention the difference between the MPEG-2 and MPEG-4. So let us look into the difference between MPEG-2 and MPEG-4. So when we talk about the differences, first one is the encoding technique. When we talk about the encoding technique, here it is H.262. It's been becoming a standard in a MPEG-2, whereas in a MPEG-4 we know that it has been generalized and also known as H.264. Look at the things. The same kind of encoding technique, a bit of improvisation is being achieved. Then the file size, this is very important, second one. When we talk about the file size, MPEG-2, it's a bigger file. The files are bigger. I told you why the files are bigger here, whereas here you encounter with smaller files, because the compression rate is very high here, lot of compression is done and loss of information is very high, so obviously the file size will be small, whereas here the compression rate is low, so loss of information is very negligible or less, so the data, storage is obviously storage of file size is very much high. Then the media of storage. Mainly when we talk about the storage of MPEG-2, we use DVDs, because DVDs are other storage device. We are not bothered about the storage here. We use secondary, that is secondary devices with large storage capacity. It might be external hard drives or anything, where we are not bothered about the storage, because here once it is stored on a device, we use that storage device for retrieve the information, whereas in MPEG-4 it is not the case. Here we mainly concentrate on the online activities, or it is a network storage. So when we want to store on online or a network, obviously the size of the data file needs to be very small, because we need to retrieve it and transfer it over the network. Then compression rate. So here MPEG, it is low and here it is high. And when we talk about the standard, or it is in other terms, it is also referred to as quality, whereas here you get high quality. Here it's a medium, I don't call it as low. Decent. Here it's high because less compression. And moreover, this kind of less compression is very much suitable for industry standard. So editing, film industry, and other photographics and graphic medias, these kind of industries need these kind of compression because they are least bothered with the rate. They want the very high quality audio and video pictures. So that's why here the standard or quality is very high as per the industry standards. Here it's very low as per the general transmission or broadcasting. And next, when we talk about these are said to be the main thing, but there are few more things that I don't write it, but I explain it. So next is the file extensions. When we talk about MPEG-2, what kind of file extensions are used? Like MPEG, you might encounter, then MPEG, and also M2V or MP2 or sometimes MP3. These kind of standards are encountered here. When you talk about MP3, it's an audio thing because it's MPEG is a combination of both audio and video concepts. When we come to the MPEG-4, what kind of file extensions are encountered here? Here the file extensions like MP4, M4A and M4B and M4R and also M4V. So these are the different kinds of file extensions that are used in MPEG-4. And finally, when we talk about the application, here MPEG-2 uses the DVD and the broadcasting with respect to the television, whereas MPEG-4 it uses portable devices and internet streaming mainly. Why do we use the portable devices? Because here the data rate, compression data rate is very high and the data is compressed to very smaller size file. So that's why these are very much suitable for applications that are portable from one thing to another or one application to other application, and also it is very much adaptable for live streaming. These were the major differences with respect to MPEG-2 and MPEG-4. Next, we have the final concept of the MPEG standards that we will be discussing in this course is the MPEG-7. So obviously there would be a lot of other intermediary standards, but MPEG-7 was most popular and generalized standard. So when we look about the MPEG-7, it is then an ISO and IEC standard. It is not just a simple thing. It's been a standard method developed by the MPEG committee that was developed by Emmy award winning standard known as MPEG-1, MPEG-2 and also MPEG-4. So this is the continuation of the same brand or company that has extended its version from MPEG to MPEG-1, MPEG-2 and MPEG-4. Now they came up with the MPEG-7 also. When we talk about MPEG-4, it was usually, I think it came into existence during 1999. After that, the MPEG-7 came into picture. So when we talk about the MPEG-7, we need to know the main differences between MPEG-1, MPEG-2 and MPEG-4. So then we can able to assess the importance of MPEG-7. When we talk about the MPEG or MPEG-1, for storage and retrieval of motion pictures and audio of storage media. That's it. This MPEG-1 was mainly used for this reason and no other intention. Whereas MPEG-2 were mainly used for digital television. It is a timely response from the satellite broadcasting and cable television industries in their transmission of analog to digital format. So this was about the importance of MPEG-2. When we talk about MPEG-4, just now discussed codec contents. What is codec? We have seen it. So as an object and enables those objects to be manipulated individually and collectively as an audiovisual scene. This is about the MPEG-4. Now we will see what does MPEG-7 define. So MPEG 7 is a standard for describing features of multimedia content. So it became the standard to define the features of multimedia content. So it defines it. So various multimedia features are defined with the MPEG 4 thing. Then why it has become a qualifying standard? Because it provides world's rich set of audio, video description. This is very important. So these are the three main features that is sufficient to know why MPEG 7 is so popular and why it is so important. The first one, it has become a standard of ISO and IEC standard, where those are the standards of MPEG 1, MPEG 2 and MPEG 4, and MPEG 7 is coming in the same line to become a standard. Second one, it can be defined as a standard for describing the features of multimedia contents. So when you talk about the qualifying things, that MPEG has been very much qualified, provides the world's richest set of audio and video description. So this format provides the detailed description completely with respect to audio and video representation of each objects. That is the main thing. And it was released in the year 2002. See, when we talk about MPEG 4, it was released or it was announced as a standard during 1999, and whereas the MPEG 7 came into existence or a picture during 2002, and the multimedia content description as a standard now. It is the difference, the main difference that permits here is the formats, unlike MPEG 1, MPEG 2 and MPEG 4. And main thing is, it does not deal with coding or moving pictures and audio at all, because it is everything is considered as object. In fact, MPEG 7 was designed as a standardized, okay, for a set of description schemes and descriptors and the language to specify these schemes. This is very important, whereas earlier we were using just description. Here the set of description and a particular language was used in order to provide the schemes for this description, called the description definition language. We call it as DDL. So many of the times when you talk about the compression or dealing with video and audio video pictures or images, movement pictures, you might encounter with an error message called the DDL format not supporting, DDL format file missing, all these things. What does it mean? It means that description definition language or its related component is not accessible. So this is the importance of it. The MPEG 7 totally deals with these kind of schemes as with a specific language of coding with respect to description. What does that mean? We'll go to it. Now, when we talk about the MPEG 7, it allows the embedding of metadata information into audio and video files. Means the data within the data can be included. Hence, the audio and video files can be searched or indexed based on information content instead of searching the actual content bit by bit stream. So this is very important, whereas in the other cases of MPEG, we need to go a streaming activity in order to find. Here we are able to find it as an index. In those index we can directly point out and access those elements directly. So this is the importance of MPEG 7. Next, MPEG 7 does this by using what kind of language? That is XML. That is very important. extensible markup language. It makes use of XML to store those metadata. It can be attached to time code, means wherever you want a particular file to be displayed, you can have the time code there and you can derive those data and fix it. This is encountered what we are doing editing. You might have seen this video. By the time you see it, we edit it and make some images come up, we make it some text come up. All these things are achievable only because of these properties. Means the attaching code in order to tag a particular event or synchronize the lyrics of a song. So I will give an illustration. Many of the times when a video song is playing, you might notice the lyrics coming up at the bottom. How do we do this? This is what the supporting done by the MPEG 7 standards. The same features, means here what we do here, the different events can be triggered or called or placed in a particular time span. So it can be placing that at 2 minutes 30 seconds, this event has to come along with the main video. Means we are embedding the one more video or one more text or a one more audio along with the mainstream. This is called embedding of metadata information. This property is mainly achieved with the MPEG 7 format. So you might be asking, sir, even in MPEG 4 we are able to do it. Yes, that is true, but the concept of embedding mainly was introduced with the MPEG 7. Now these properties are also introduced in other format, so you are able to achieve it. So MPEG does not use this just by XML to store the metadata. It is using these XML activity to introduce various multimedia components into the main data stream. An advantage of using XML is to store the metadata, that XML is universal. That is the reason XML has been used, not any kind of languages. Hence, XML in association with MPEG can be read by most of the existing tools that support the XML parsing. So this is about the MPEG 7. The relation and the description when we talk about the content of XML. So, MPEG 7 is an MPEG architecture requirement is a description. So why do we call it as the relation between a description and the content? Let us look into the concept. There is a lot of importance given when we talk about MPEG 7. What are those concepts? Is the description and content. See, these are the two important components when we talk about MPEG 7 that come into a picture. Now we need to know the relationship between the description and the content. So when we talk about the MPEG 7, it's an architecture, okay, that requires the description must be separate from the audio visual content. Means whatever there is the description that you provide in association or embedding, it should be totally different from the original audio and video content. This is what it says. Means this is content means the original video. So description is the additional. So on the original track of content, these descriptions are added extra. It might be a text, or it might be one more portion of image, or it might be a bigger image, or it might be a image along with that things, or it might be some music or audio. So this is the main concept that has been introduced with the MPEG 7 standards. So when we talk about the tools that MPEG supports, MPEG mainly concentrates on 4 major tools. What are those? The first one, when you talk about is descriptor, it is also defined as D. In short, it is denoted as D. It is the representation of a feature defined syntactically and semantically. It could be that unique object that was described with several descriptors. So this kind of description is denoted as D. Second one is description scheme. It is denoted as DS. So specify the structure and the semantic of the relation between the component. So in the previous discussion we saw about the description and the content. Here, in what kind of relationship, that is a scheme, that those relationship established is being described. These components can be the descriptors, so that describe the relationship between those two. And third one, as already known, that is the description definition language. That is DDL, the most popular one. This is the thing that made the MPEG-7 more popular. It is mainly based on the XML languages to define the structural relationship between the descriptors. So descriptors are those. How do we use the description? In the previous shortly I showed you a representation. The descriptors are represented on the original contents. Okay, so this is how these descriptors D define the scheme, how to define, where to define, at what point of time to define, what time, at what place and where, until where and where it has to be involved. All these things are defined by the scheme, and the type used to represent those description on the content is the DDL, that is XML is used. And finally, the system tools. So finally, the system tools are used to deal with these things, that is binarization, synchronization, transport, storage, description, and also deals with intellectual property protection. So these are the four major tools that are associated with the MPEG-7 format. So when we talk about those MPEG-7 format, so main thing is the D, that is the descriptor that defines what are the different kinds of descriptions that needs to be embossed or embedded. Embedded is the right thing. That when you talk about embossed, it's a protuberance, whereas embedding is introducing into it. That can be introduced into the original content would be described as a D, that is a descriptor. And the type of the property, where to allocate it, how to allocate it, at what time it has to emerge and what time it has to end, all these things will be described in the description scheme, that is represented as DS. And finally, the DDL, that is the description definition language, that is in association with XML, used to follow this description scheme for the describers to put into the content. And finally, the system tools are very much supportive in order to do all the additional activities and also intellectual property protection of the MPEG-7. So this is how the MPEG-7 works. And many of the times, many applications and application domains that can benefit from the format of the MPEG-7 are like the digital library, where the image and video catalogs are there, music dictionaries are there. This is very important, they support it. And next, when you talk about multimedia dictionary services or a directory services like Yellow Pages, There also MPEG-7 formats are used. Broadcasting media, when you talk about broadcasting media, that is the selection of radio channels or a TV channel it might be. MPEG-7 came into a picture where it became very popular and still in existence. Multimedia editing. So what we do, see, now we are recording it live, where you don't encounter any of the additional text or anything here, but when we edit it, we use those descriptions what to add. You might have seen at the beginning of this session, my video lecturing, you encounter the title. What are those? Those are called the descriptors, D. And description scheme, where should it come? I use this title of the subject as multimedia system, my name, everything will be coming. Those are called descriptor. Where should it come? Not in between at the random place. It should come at the beginning. I define a scheme to it and I use a software to add those things. That is called DDL, that is XML. So this is how multimedia editing is done, like personalized electronic news services, media, authoring, etc. Security services, even it is been used in traffic control, production of chains, etc. and e-business obviously, and cultural services like art galleries, museums, where these formats are used. Educational applications, the best example is the video what you are seeing now, and also biomedical applications. These are the many applications that make use of the MPEG-7 format. And the last topic that you are about to witness is the fractals. There is no much discussion, but this point has to be discussed in order to know the importance. Fractal. What is fractal? What kind of objects are said to be fractal? Everything we have discussed in the elements of multimedia, that is the introductory sessions of module 1 itself. Now we will see what kind of compression is done with respect to fractals. So when we talk about the fractal compression, it is obviously a lossy compression. So it comes under the lossy compression method for what kind of things? For digital images based on fractals. This is very important. We do it for digital images. So what kind of thing? It is when you talk about fractals, it is the outcome of a mathematical equation. It is the outcome of some equation. So the image that is being generated as an outcome of particular equation is said to be a fractal. You might be knowing some of the equations produce the outcome as circle, some of the equations produce the outcome as a triangle, and some produce a rhombus, and some produce a parallelepiped. These are all the outcome of particular process or equations. So those are things, those kind of designs, geometrical designs are said to be the fractals. This kind of method is best suited for textures. So fractal compression is very much best suited for what? The textures and the natural images that rely on the fact that parts of an image often resemble the other parts of the same image. See, look at this. Every image resembles to one another image, not completely, portion. See, here it's straight, here it's straight. So here it's straight, here again it's made straight, even this is straight. So there is some kind of relation or similarity between those kind of portion of images. So when we can achieve the compression with these kind of images, so it is very much suitable for the images of fractals. So fractal algorithms, there are a lot of algorithms called fractal algorithm which has been discussed at the initial stage to convert these part into mathematical data called the fractal codes, which are used to create the encoded images. What it happens, we'll look into it. So how does this image is done? So fractal image, that is very beautiful. It can be represented by a picture representation. Consider, okay, we have an input image. This is a frame. This is a frame where we have an image like this, a smiley. Okay, let us consider this as an input. Now what our intention is, we feed into a loop. So here there is a black box. Okay, we are least further how does it work, working principle and all. This is the additional component that's been discussed here. So we feed this image into this box or a process where the looping is done, means the one object is been repeatedly looped in order to produce an output same size of frame with three or more smileys. See, look at this. This is the beauty of fractals. This is one image, a fractal image, which has been generated as an outcome of an equation, mathematical equation, okay, which has been fed into a process where what happens here is, so we call it as black box. We are not concentrating here, but we need to know what happens in this process. In this process, the same image is taken, compressed in a loop format and generated as an output with three smileys. The bigger image is been compressed into smaller image and put into a one frame. This kind of concept is said to be the fractal compression. So there are many such images that you can encounter. Let us consider here itself. I'll write it here. A. Okay, this is a letter A. So this A can also be generated see here, the same type of A is used 3 times and this has become one more kind of image. So this kind of image representation is called a fractal compression. So what we do here, an image is compressed, a bigger image is compressed, this compressed image is put together with similar kind of images which resemble one another and a new image is generated with those things. This is called a fractal compression. So these are the things I had wished to discuss in this session. Thank you. This completes the topic, the data compression. Thank you very much.